Howdy and welcome back. So let's go ahead and get right into this subject on pointers, and we'll start out with our first declaration. So here's our first declaration of a pointer. We'll go ahead and decompose this to go ahead and discuss what the different parts mean. But reading, what is P? P is going to be a pointer to an integer object. That is, P will eventually, hopefully, store the address of an integer object. So int here is going to be the base type. Asterisk is going to be our declarator operator, pointer. And P is going to be the identifier, or the name of the object being created. Remember, a pointer is an object. It's just its value is going to be the address of another object. But here's a quite quick little spin on that. We can initialize a pointer to the null pointer, which essentially communicates that this thing is not pointing to anything. It does not store, let's say, the address of any object. It's blank. You can think about it that way. If we were to be, say, writing down, I don't know, maybe, let's say, a phone number or something on an index card. The index card could start out blank and we haven't written anything on it. That's kind of what this is communicating here. It's saying the pointer doesn't contain any useful information at this point. So we can visualize this informally as P. We can say that it is bound to this object residing at this address. So that's the address of P. It's where it lives out there in memory. And then in this diagram notation, we can see that the initial value of P is null pointer, which means it is pointing to nothing. So in this case, nada. So that's kind of just the declaration as it is. Let's go ahead and build this up a little and actually allow P to point to something. So this object starts out as essentially blank, storing the null pointer. It's saying, I'm not storing anything useful. I'm not pointing to any sort of object at this time. Well, in order to point to an integer object, we need an integer object to point to. So my next step, at least in this process, is going to be, okay, I'll declare I. It's going to be an integer object initialized with 7. So at this point, we have P out there in memory pointing to nothing. We have I out there in memory storing the value of 7. Both P and I have addresses. And the whole point of our pointer in this example is going to be to get the address of I and store it as P's value. Now, we said get the address. So how do we go about and do that? Well, let's look at the next assignment statement here. Ampersand as an operator is going to be the address of operator. So it's going to be a unary operator whose operand is going to essentially give us that operand's address. So in this case, I, ampersand I, is going to give us or yield the address of I. And again, just following this diagram that I set up, the address is below the box, the value is in the box, and the name of the object on top. So this right here evaluates to this. And now we have an assignment statement, which means that that address is going to be put into P. And notice that in this case, that address becomes P's value. So at this point, we've set up the relationship that P points to I because P stores the address of I. Notice again, P is an object, just like the integer, just like I. The only difference is P storing address. We can do various arithmetic operations on P, just like we can do various arithmetic operations on I. We'll get into this in a little bit. I believe pointer arithmetic will be during the arrays lesson, so tomorrow. Just like I, P has an address. Whoops, let's do that in a different color as not to confuse you. And just like our attributes, a pointer has all of these. It has a name, address, type, value, scope, and lifetime. None of this is different. It's weird because P is storing an address. But when you view it as no differently than like an integer stores an integer value, an address isn't so weird. So continuing on here. So let's say that we don't want to start out with like a blank piece, a blank note card, or whatever the analogy is here. But instead, we'd like to start out with P with an actual address, well-defined address, in this case, that of I. So let's say somewhere in our program, we've created I. So right here, this is what that declaration's doing. We say I is an integer object that's initialized with 7. Cool. It has an address out there in memory. Now let's go ahead and initialize P. P in this case, reading from right to left, P is a pointer to an integer object, and we'll go ahead and initialize that with the address of I. So again, to get the address of I, we simply use the address of operator and go, hey, I, where do you live? What's your address? So again, this expression right here will return the address of I. So where it is I resides out there in memory. Cool. Once we have that, we can finish the initialization. That address gets put into P, and that is what P will start out with. And right here, we can see that connection and how at this point, P points to I. Okay, so continuing on here. So this slide is just going to give an example of kind of what's going on and point towards some interesting kind of features of this. So let's say we have two objects, I and P. I is going to be simply an integer object residing out there in memory. It's going to be initialized with the integer value of 7. P is going to be a pointer to an integer object. It is going to be initialized with the address of I. So notice here that that sets up this relationship. P will point to I because P stores the address of I, and we receive the address of I using the address of operator. Now let's go ahead and see out some different properties here to kind of make sense of all of this. So remember, P is an object. We can take P's address. So if I ask P using the address of operator, what is your address? Its address would be printed to standard output. Now, if I go ahead and ask, hey P, what value are you storing? The value inside of P is going to be the address of I. So notice here that what is being printed out is going to be the value stored in P. Now here's a new one. And what is going to be very, very important here moving forward is to recognize that the asterisk as a declarator operator is different than the asterisk presenting within an expression here. Notice here that we know, I'll use a different color. We know that this asterisk is going to be used as an operator because it is not presenting as a declarator operator in the declaration of a named object. So notice up here, P, declarator operator, pointer, base type. Here, no type, it's an expression. This is going to be the dereference operator. It is a unary operator, and when prefixed in front of an operand of the pointer type, what's going to happen is as follows. If we write dereference P, we're going to first look at the value in P. Second, go to that address in memory. 3, interpret starting from that address as an object of the base type of P. So in this case, remember, here is the base type of P. And why this is so important in the declaration of a pointer is because that if we would like to directly or indirectly access the object to which P points, we have to A, look at P's value. So that's the address. So we have the address, we go out there to memory, and we're at the starting point of whatever object that is. We do not know how to interpret that memory unless we know the type of object residing at that address. In this case, the base type tells us how to interpret the address stored in P. So starting from that region in memory, we read out enough bytes that would essentially be used to store an integer object, and then we interpret that sequence according to the base type. And in doing all of this, we observe the integer value of 7 printed to standard output. Effectively, what we've done is we've dereferenced the pointer. We've looked at the address, we've gone out to memory, and we've essentially grabbed the object at that address in memory, and we brought its value back. And here we see 7. So just to take you through a couple of additional pointer operations. Let's say we'd like to make an assignment to the object being pointed to through P. So indirectly make an assignment. So let's go ahead and set this up. We have I as an integer object, initialized with 7, just like before. P is going to be a pointer to an integer object, initialized with the address of, in this case, I, because that's the address of operator. And here, remember, this is a declarator operator. Pointer. That's what's saying P is a pointer to an integer object and not just an integer object. So this establishes the following relationship as we talked about earlier. Hey, P is going to store the address of I. Now let's consider the following statement. 5 plus 6 is assigned to P dereferenced. Notice again that here the asterisk is appearing in and expression, so it is the dereference operator. It is not a declarator operator. Notice the meaning here is different. In the declaration, we're saying P is going to be a pointer to an integer object. Here, it's in an expression, and its meaning is going to be the dereference operator, and it will dereference its operand. It's a unary operator. So in this case, that dereference procedure is look at the address in P, go out to that region in memory, and give me the integer object at that location. Because again, P points to an int, so we essentially interpret the memory at P's value, its address, according to the base type. That effectively returns this whole object. So at this point in the expression, asterisk P gives us I. We've indirectly accessed it. So at this point, 5 plus 6 evaluated to 11, and what gets put into I? The integer value of 11. So to just run through this in a more scripted manner, so given the following statement, 5 plus 6 is assigned to P dereferenced. We're first going to, since initialization and assignment is right to left associative, we first evaluate 5 plus 6 to 11, and then we go ahead and evaluate that on the left-hand side of the equal sign. So dereference P, we go out to the address. We isolate the integer object that starts at that address, and we assign the integer value of 11 into that object. And now, notice P has not changed at all. But the object to which P points to has. It's taken on a new value. And that's exactly what this dereference operator is doing, is it's giving us the object to which P points. So again, effectively by writing P dereferenced, we're getting this object. We're getting it back. So that would be, if effectively it's the same thing as writing I is equal to 5 plus 6 at this point. So one more example with pointers. Let's go ahead and use the value stored in the object pointed to. So we'll set up the same exact relationship, which we've been talking about through this point. P is simply going to be a pointer to an integer object. It's initialized with, lo and behold, the address of I. So the relationship here is P points to I. So let's now assume the following statement. We have a declaration. It's of an integer object J, who's going to be initialized with the value of P dereferenced. So again, remember that writing this effectively gives us this object, because again, P points to I, the dereference operator goes out and gets us the object to which P points. So initialization assignment is going to be right to left associative. So dereference P is going to be evaluated first. We go out to that address. We begin interpreting the data there as if it's an integer object. We get back I. That's going to evaluate to 7. So now the statement reads effectively, we're introducing J. It's an integer object who's going to be initialized with the value 7. So at this point, J starts out with the value of 7. So before moving on, this was a very introduction to pointers. Again, the key takeaway here is pointers have all of these attributes, the same attributes that any variable has. They have a name, they have an address, they have a type, they have a value, they have a scope and a lifetime. The kind of interesting thing about a pointer is its value is going to be, well, an address. The other interesting thing about a pointer is that its base type here is just so critical. The declarator operator asterisk tells us that the name being introduced will be a pointer, but the base type is going to tell us how whatever address P is going to store, how that address, if we were to access it indirectly, that memory should be interpreted. So in this case, if we were to dereference P and it actually were to say point to an integer object, so dereference P, we again go out to the memory address and we begin interpreting it according to the base type, here an integer, and it essentially isolates this object here. It gives us that back. So pointers are quite interesting. Again, I know they're kind of strange in that they do maintain an address to some object, but just take them at face value this first time that you've seen them and understand that they're an object like anything else. They just store an address.